Well, I'm really looking forward to Mark's presentation because I'm very, very impressed by how much work he's done, the standard of his new build and retrofit, and the fact that he's done so much of his own design and DIY. I hope you agree with me at the end. I think this is really impressive. So Mark is an engineer, as you will soon gather, but over to you, Mark.
Okay, so I'm Mark. I live in St Ives, and I'm an electronics engineer. I've been doing engineering all my life, one form or another. But I'm very interested in building, and I've always liked doing DIY and all kinds of projects like that. And I always wanted to build my own house. My interest, I suppose, started in my early not early teenage years, my early adulthood. My parents moved to Wales and they bought an old mill in Wales and renovated it, and they've lived there ever since for about 40 years now. Um, and it was just a fascinating journey watching them do all that work. And so my father did it all himself. It almost took the whole thing down and rebuilt it. Uh, and one of the things I remember talking about with him, which piqued my interest in sustainability, was he talked about solar panels. He always wanted to make solar thermal panels many years ago, and we talked about different ways of designing them, etc. But he never quite got around to it. But I don't know, probably about 10 years ago now, my previous house, I had some spare time, so I had a go and I made some solar panels and fitted them on and made the whole system myself, and it was quite successful. It generated lots of hot water. But anyway, back to this project here. I, I wanted a project to do mostly when I got to a certain age, and this bungalow came up for sale, and I thought it was an ideal sort of plot size and bungalow type. It wasn't a listed building, so I could do pretty much what I wanted to it, and there was plenty of space for further development. Um, and through my research, etc., as I'll discuss in a minute, um, I discovered the Passivhaus standard, and I just thought it was absolutely fantastic. I thought, why don't everybody build like that? Why aren't all houses built like that? And I read the Passivhaus magazines, and people say, or organisations say they can build Passivhaus for almost the same price as a normal house now. So anyway, this bungalow built in 1957, solid brick walls to the upper half, single glazed windows. I mean, it had gas central heating, and suspended wooden floor with a crawl space underneath. So it's ventilated underneath. Ventilation bricks in the walls, allowing nice icy drafts to blow through the house in the middle of winter. Very hard to heat, and used massive amounts of gas to heat it. The first year we were there, it was somewhere for 6 months from November through till the summer. We used about 27 megawatts of gas just to stay. It was comfortably warm because my daughter had just had her first child, so we wanted to keep it nice and warm for her. But it was a lot of gas. And fortunately, it was a lot cheaper then. So I'll move on to the planning application. We considered various options. One of them was knocking the bungalow down completely and restarting with a new build. Very expensive, and considering how much I paid for the bungalow, sort of the finances didn't stack up, and I didn't really have enough money to start from scratch like that. Plus, we needed somewhere to live, so I thought an extension would be the next best thing. A reasonably large extension, which is the bit that sticks out the front there. And I made several pre-planning applications to the planning authority back in the day, because you're allowed to do it then, and they gave me some advice for free. So I developed my plans and came up with this, which they were quite happy with in the end. I had to consider things like my next door neighbour's right to light, because the previous owner of this building let them build an extension with a big window overlooking it, which was only a minor hindrance. One of the biggest hurdles I had in planning was with the flood risk assessment. I think it was probably just after the regulation had been brought in about building on floodplains, that my local authority took it upon themselves to create their own risk assessments, and basically said you can't build on the floodplain, which encroached on my land according to their plan by 1 meter or something like that. It just touched the edge of it, but they just said flatly, no, you can't build on it. So I employed a flood risk assessor, and he said they were talking a load of rubbish. They didn't understand the regulations, so he prepared an application for me, which gave all the reasons why I could build, and I forwarded that to the planning office, and they said, no, we don't accept that. You still can't build on it. So then I told the flood risk assessor, and he was slightly put out by that. So I gave him the contact details of the planning officer, and they discussed it to some length, I think. And then I got approval through the post pretty shortly after that. So that was a small win, but it was quite stressful at the time. So we'll move on to our next slide. So my targets, considering I fell in love with the Passivhaus system, was fabric first. So I've designed for the best air tightness I could possibly do in the extension, aiming for a U value in the walls of 0.11, and a 0.1 in the roof, underfloor insulation, so I've got 0.1 there, triple glazed windows. Didn't go for Passivhaus certified products here. I got ones just below that because they're significantly cheaper, and I have no intention of registering or applying for a Passivhaus certification. Minimize the cold bridges as much as possible, which I did in the extension by using Celcom blocks rather than anything else. A couple of courses of those gives you a reasonable insulation from the ground. And we move on and talk about a little bit of the detailed design. So I did all these drawings myself for building control. So here you can see, let me just, sorry, I've gone forward. Let me, excuse me a minute, I'll just go back. Yes, you can see here, this is the window, and to project the windows into the insulation area, because that's the best place to site them. I built plywood boxes which project out from the wall, so the windows aren't actually physically fixed to the wall, the masonry. They're fixed in the window box, which is close to the middle of the insulation. So this is the insulation layer on the outside. EWI, which is polystyrene stuck to the outside. And for this, I managed to get the U value down to 0.11 for the wall. This is the wall detail in a little bit more. So there's a thin render coat on the outside of the polystyrene. That's the polystyrene layer there. And that's the 250mm block wall, single block wall. And that was chosen really for ease of construction for myself, because I got a builder friend of mine, and we built it all between the two of us. You know, right from the footings, digging out the footings to building the whole construction. And then the wall detail here, not the wall detail, sorry, the floor detail. The floor detail. One of the interesting things here, which we'll see a slide of next, is I didn't want to have underfloor ventilation because the building is on expansive clay soil. You have to have a gap between the soil and your concrete slab, your sub base, just in case the soil expands and pushes the floor up. So I had to leave a gap of 6 inches under there. But rather than have that ventilated, which is the common method, beam and block floor with ventilation underneath, I discovered after lots of research that I could have a reinforced concrete slab over there, which didn't require any ventilation. And that's what I chose and built the rest of the building off of that. So this is the concrete slab just ready for casting, and underneath the reinforced mesh there, we've got the cell core product, which is this hexagonal polystyrene structure, which is strong enough to support the reinforced concrete which sits on top of it while it sets, but it's weak enough that it'll crush under expansive loads from the clay soil. And then just a couple little pictures on the side. I had to take some drainage through the footings. So, following the building regs, you have to have 100 mm clearance around your pipes. So I've got my drainage pipes inside these 300 mm large drain pipes. And then the roof structure, I chose to go for a cut roof, which is a description of a hand-built, handmade roof, rather than using standard roof trusses. It's very similar in price, probably takes a little bit longer in the manual construction phase. But the main reason I chose to do that was to get 200 mm deep rafters that I could pack with insulation. And yeah, we built it all on site. And on the right there, you can see I used a glue lam beam, ridge beam in 3 sections that I had to join. And then there's a ridge beam support there that I'm preparing on the ground. And then, yeah, the roof is almost fully constructed there, or the framework is anyway. The next picture is the roof is finished. Well, finished. It's constructed, and I've started to cover it in a wood fibre sarking. Now, I particularly chose this method of finishing the roof off because it meant that I wouldn't have to have a ventilation gap between the top side of the insulation and the underside of the felt, which is what is required when you have rooms in the roof space like this. For this product, this is called, I bought UD-Top. There are a couple of products on the market. This one, forget exactly where it's made, but you can find out from the link. It's from Europe somewhere. But it's a wood fibre sarking, which is vapor permeable. So any vapor that travels up through the insulation can permeate through this material into the void above it, which is then ventilated to atmosphere. And that, in my view, is a better way to build than allowing cold, very cold air sometimes to pass right above your insulation layer, or the main insulation layer of your rock wall in this case. I put a link there to building control correspondence because I had an interesting, very nerve-wracking experience with building control at this point, because I built most of the roof and I called in the building control to sign it off, and the building inspector said, well, there's too much insulation in that roof. And I just looked at him with a bit of a puzzled look, and I said, too much insulation? And he backtracked at that point and said, well, not too much insulation, but you haven't got the ventilation space above it. And I referred him then to the full plans application that I had done and the information that was in there. So he had to go away and look at that. He still didn't accept it. I had to jump through a couple more hoops. But eventually, almost quite reluctantly, he had to approve it and sign it off. But I did get it through, fortunately. It was a nervous experience, that was. And then I chose external wall insulation because it just appealed to my abilities that I thought I had. I think I have a lot more now. But yeah, building single block walls and sticking the insulation on just seemed like quite a straightforward process. And it also has the added advantage that it shrinks the requirement of your footings dramatically, because you only need to support a single block wall. So the amount of concrete is less than half of what I would have used if I'd built a cavity wall. So that saved a lot of money on digging, taking the mud away, and a massive amount of money on concrete. So this is all finished. It all stuck on, and then on top of this, I placed a thin coat render system, which is about 6 millimeters of a flexible material with embedded fiberglass mesh just for added strength, and it's worked fine. I've had no problems with it at all. And moving on to the next slide, this is the inside of the roof as it was being constructed. So like I said, 200 millimeter deep rafters there, and I've got the rock wall fibre you can see there on the right hand side. That's between the rafters, and then on top of that, or underneath that, I held it all up with 80 millimeters of the PIR foam. And then when that was all taped up and sealed, which will pretty much be a vapor barrier in itself, I applied a vapor barrier membrane of that green plastic you can see, and thoroughly taped it together all over the place, back and front. And then it's taped to the membranes that come up around the floor joists. I didn't mention that earlier on. Around the floor joists, because the floor joists are often a problematic area for air leakage when you're building. And I found on the Green Building Forum, someone had come up with a very neat idea of wrapping a vapor membrane, or not a vapor membrane, an airtight membrane material around the joists where they sit on the wall. And then you lap the membrane into the render on the wall from downstairs, and then I taped the other side of the membrane to the vapor barrier that I've got for upstairs. And I did all this sealing myself, so I'm very confident that I got all the joins. I went round it with a 5-tooth comb. I didn't have anybody else doing it. I did all of this myself because I wanted to make sure that I had every little bit covered. And there you go. That's pretty much taken us through to the any question stage of the extension construction.
Well, thank you, Mark. So have we got anything yet, Nicole? Do put your questions there. Maybe I'll start off by, I'm curious, Mark, on the extension here, what
Yes.
was the most challenging bit for you, whether it was DIY or getting all the...
digging the footings out, because I got a friend, and it's my boss at work, and we talked about what I was doing quite a lot. And I said, "Oh, I'm trying to find someone to do the footings for me, but I'm finding it very difficult to find someone A, that's available, or B, that's willing." No one was really available. And he said, "Well, why don't you do it yourself?" And I thought, "Yeah, I probably could." And then he said, "Oh, you could use Gary, who's a mutual friend, the builder." So I talked to Gary, and he says, "Yeah, I can do that. I can drive a digger." And I thought, "Well, I can drive a dumper truck." So I've never done anything like that before, and I thought, "Oh, how hard could it be?" So we set off. I had a week and a half off work, and we set at it. And I thought it would take probably 3 days. It ended up taking 6. It was extremely hard work, absolutely exhausting. And there were a bit of a calamity at the outset when the excavations just started collapsing in. As soon as because they had to be quite deep, we were down at 6 feet, and the excavations just collapsed in after we'd done a couple of meters. So then, quick think, went and bought a load of plywood shuttering, and we had to shutter up the sides of the trenches as we dug them. So we'd dig 3 meters and then shutter it, and dig another 3 meters, and so it went on. So it doubled the time it took to do it, and added an extra £1,000 in materials, I think. But yeah, that was the most challenging, I think, and mostly because I didn't really, well, I don't say I didn't know what I was doing. I knew what I was doing, but I didn't have any experience of doing it. So it was all new, but yeah, that was very challenging.
I put a link in chat to the Green Building Forum that Mark mentioned, but really good source of advice.
Yeah, they're very good and very helpful group of people. The other challenging thing was dealing with building control. I didn't know how to take them, and most of the time they just came along and said, "Yeah, that's fine, that's perfectly all right." One inspector came and looked at the cell core and said, "I haven't seen it done like that before." I said, "Well, I made my decisions based on what I thought was best in terms of retaining heat within the building." And he says, "Yeah, it's fine. You just haven't seen it done like that before. It's not a common thing you do." I would say it probably added £1,000 to the build, but because I did it all myself, it wasn't a great deal of money in the grand scheme of things.
That's
Any
great.
more questions?
Thanks, Mark. I think John's got a question. John, would you like to unmute and ask Mark directly?
Yep, sure. On the subject of roofs, do you think building control are generally not happy with unventilated warm roofs? Because I've got the same issue with an application I've got in at the moment.
Yes, I would pretty much say certainly yes, because they don't have a lot of experience of it. They know what they know, and they're not learning new techniques probably quick enough. And the building inspector that questioned me on my roof, he swore blind that I would have water running down the underside of my sarking. He says, and I said, well, I've got a vapor membrane on there. And he says, it doesn't matter. You'll still have, water running down the inside of that, which I thought, I don't think I will, because I made sure it was completely sealed, taped up completely. But just to be on the safe side, well, just to know what was going on, I put a little humidity sensor on, on the outside, or sort of the underside of the sarking and the top of the insulation, just out of interest. And I think the highest level of vapor I got up there was something like humidity about, I think it was about 90% it got up to, and that was in the summer. In winter it's very low. But
I say
it can be tricky.
And I say that the combined authority building inspectors have now all been trained in retrofit, and I don't know how much difference this is making, but our last bit of retrofit, actually, we got some really good advice from a building inspector who we sat down with the building inspector, our builder, and us, the clients, and together we worked out a solution to a rather tricky problem that would, satisfy the building inspector.
Yeah, most of the time, if building inspectors have got the time, they will give you lots of advice. They're very helpful people. I've had long chats with many of them. It was just one particular person that really wanted to make a point about something, I think. For the roof, the last thing I had to do for him was do a condensation risk assessment. And I found the information about how to do it online. There's a little calculator I found, and I did the risk assessment and proved there was no problem with condensation risk underneath the sarking. Because I was keeping any moisture just away from the area, and it's worked.
If that wasn't woofy, would you mind sharing the details?
Yeah, it was woofy.
Oh, it was woofy. Okay.
I think Stuart also has got a related question on warm roofs. Stuart, would you like to ask Mark? You're unmuted, Stuart. Go ahead. Okay, Stuart might be experiencing some technical difficulties. I'll ask the question. Mark, do you think the warm roof method provides better insulation than a cold roof method?
Well, in my own opinion, the way I view it, yes. Compared to having the so you're talking about a cold roof as a a completely sealed roof. I mean, a warm roof is somewhere normally where you inhabit. If you're talking about a cold roof, a cold roof could just be the roof space in a otherwise insulated house, and it doesn't. That roof space is normally ventilated anyway in most houses. But the whole concept of the build that I did, following the Passivhaus, process was, you do your fabric to the best possible construction, really, insulation methods, and then you've got to build in good quality air tightness, and then you have to ventilate. Without proper ventilation, these buildings would be pretty unpleasant to live in. They'll get very stuffy and smelly very quickly because there's no ventilation.
Well, I think it's time to move on and for you to tell us about the bungalow, and indeed you're going to tell us about ventilation more, aren't you?
Okay, so the bungalow, then the renovation to that, we saw the pictures of it earlier. My design philosophy towards that was to make it suit our lives. So I've knocked around the inside, moved all the walls around, and got it laid out how I wanted, moved all the windows about. But the key factors here, going back to the Passivhaus standard, are to build in the best insulated fabric first. So I built a design for an EWI of 270 millimeters to get me close to the extension U value. The loft insulation at 400 mil will take it up to the same as the extension roof. The 205 millimeter underfloor insulation, I was a little bit upset that I couldn't get 225 to make it the same as the extension, but I just couldn't quite fit that in. But never mind, it's close. And then the same 3G windows, again projected into the insulation area, and the MVHR system, which is already feeding the extension, is a Ventaxia model, and it was just a good price point for that for the features. It's not a Passivhaus certified unit because I was never going to do that, but it's only probably 4 or 5% underneath the Passivhaus heat recovery.
Just
cold
explain
bridges.
to us all. Can you just explain to us all about MVHR?
Say again, Tom?
Sorry. I was suggesting you explain this abbreviation MVHR.
Oh, sorry. Yeah, for newcomers, that's mechanical ventilation and heat recovery. And basically, it's a box which sucks air in, blows air into your building, and at the same time sucks the same amount of air out of the building. And the box has a heat exchanger in it, which transfers the heat from the extracted air and transfers into the incoming air. So the incoming air is warmer than the outside air. So you don't lose a lot of heat out of the building through the ventilation system. You keep up to 90% of the heat that you extract with the air goes back into the building. So you don't lose a lot of heat using a system like this. And it also reduces the humidity slightly, which can be quite pleasant. So cold bridges, the cold bridges were a little bit difficult to deal with on the bungalow because there's only so much you can do. By cold bridges, I mean areas where you can't get much insulation, or like on walls where the walls meet the ground, it's hard to isolate those walls from the soil, which is at a much lower temperature than you'd normally have inside your building. So that's what we call a cold bridge. And obviously for an old building, the solid brick walls are built straight down onto footings which are on the ground, and it just certainly wasn't practical for me to start taking bits of the wall out and replacing them with lightweight thermal blocks. So I didn't do that. But one thing I did do was I've eliminated the cold bridge area that was around the top of the wall relative to the roof, because originally the bungalow roof sat only probably 100 millimeters from the top of the wall around the perimeter, and so there was no real space to fit insulation. So one of the first jobs I did on the bungalow was to redo the roof. So I'll move on to the next slide. So I got a structural engineer to do some roof calcs for me. and came up with this design. So all I've done, if you look at the bottom right hand picture, they are the brown timbers are the original roof structure, and the structural engineer allowed me to basically just build on top of that. So I built up with, I think, two lots of 200mm timbers, so about 400mm. I raised it with timber, and then put a new tile roof on it, as you can see there. But doing that, it gave me two key improvements. The first one was it gave me a much larger space between the tiles and the top of the wall, so I could get lots of insulation in there to get rid of that cold bridge. And the other big improvement or factor, the reason I did it, was to extend the overhang of the roof to accommodate the external wall insulation that I was going to put on the outside, which it's done very nicely. Right, move on to the next one. And when I did the roof, I put some solar thermal panels on there, as you can see in the top right and left hand corner. This is a system I made up on my own, for want of a better word, because I like to do things myself and fully understand them. So it's a pretty normal system. You just pump the glycol mix around your tank when the sun shines, and you get hot water. But one thing which I wanted to cover, because I knew, especially with thermal panels like these, they generate an excessive amount of heat when the sun shines a lot. So once your hot water tank gets up to 60 or 65 degrees, you don't really want it getting any hotter. These kinds of panels would probably boil the water in your hot water tank. It would get that hot, and that's very dangerous. So I thought, well, I want to lose that heat somewhere, and I don't just want to pump it around in a small loop and let it get forever hotter, which is the normal method that commercial systems use. So I put a heat dump loop of pipe on the ground bearing slab before I poured the concrete, which is what you can see on the right hand side. So it's just underfloor heating pipe work, and with a small manifold. So I've got two loops, and when my hot water tank is up to 65 degrees, I switch a diverter over, and it pumps the excess heat around this ground bearing slab loop, and it just slowly dissipates into the ground. And I've had it working this year, and it's worked perfectly. And I tweaked the software in my system, and it keeps the temperature down to about 30 degrees, something like that. So the fluid never gets anywhere near hot, and it just vastly increases the life of the solar fluid, because getting it really hot just degrades it very quickly. So we'll move on to the next one. And then I started renovating the inside. This is the underfloor insulation. See, the last slide showed that underfloor heating pipe, and that was underneath the ground bearing slab. So I've got the ground bearing slab on the whole of the ground floor, which I'll talk about again in a minute. But on top of that, I've then put my 205mm worth of PIR insulation with the damp-proof membrane sandwiched in between it, so there weren't any sharp bits sticking up through it. And that's all taped together through all the different rooms and taped to the wall. And it should never really give me a problem, I hope. So next picture. Now this picture shows my underfloor heating manifolds. It's probably a little abstract. On the right is the main manifold, which feeds all the separate rooms in the building, on the bungalow. On the left is a smaller manifold, and that has ground bearing slab pipe work in it, and which is below the insulation. So that should always be around about the ground floor temperature, which is about 10 or 12 degrees. My thought being that in the middle of summer, when the screed layer with the underfloor heating gets hot, it can get up to 25 or 28 degrees. I can switch over with a pump and some control valve work, which I've got, haven't built it in yet, I can switch over and pump cold water from the subfloor through my screed and cool it down by a few degrees, which hopefully should take heat out of the room. So that's a little project I've got for a few years' time when I've got most of the building work done. It's something I saw on Homes in the Sun, I think, one day when I was having a break, flicking through the channels. It was a really expensive house in Portugal, I think, that had this system in, but they had a very expensive system, as you can imagine. It's a multi-million-pound house. This is my take on it, and it remains to be seen how successful it is. I'm looking forward to playing with it. So on this slide, this is the mechanical ventilation and heat recovery system. The white box you see on the right-hand side there, that's the Ventaxia model sitting in the bungalow roof space. And the picture on the left, top left, is one of the inlet manifolds. And as you see, there's a small ring of brown dirt around there. And now that's dust that's carried through the system. That picture's after I've cleaned it, because I think it was about 18 months after we'd been living in the extension and been running the MVHR system, there appeared a very black ring in place of this brown ring. It was a very black, sooty colour, and I gave it some thought, and the only thing I could really think of that would cause it would be diesel car particulate matter, because I live quite close to a main road. It's probably about 25-30 meters from the busy town road, and there's lots of lorries and cars go by all day. And I thought, well, you can't get very good filter elements for the MVHR system, not up to the grade that you would need to block out particulate matter this small. So I found an industrial grade filter, which is, you see on the left hand side at the bottom there, that yellow element there in the box. I bought an F7 grade filter, which will filter out 90%, I think, of 0.4 micron particles, which has, through practice, so I installed this box about 18 months ago now, and I cleaned the black ring off to see what would happen, and I've got a light brown ring that's come back, which is just probably the dust which was already in my pipe work. But the yellow bag filter that you can see there, it's hard to see in this photo, but I've looked closely at it, and since it was installed, it's got some rather black coloured hues on the inside of it, because it's semi-transparent. So it's certainly, I think it's doing its job and capturing a lot of the soot particles that would otherwise be coming into the building. I never would have guessed that would happen at the distance I am from the road. It certainly was an interesting route to go down, just to prove a point. I think it's an important thing for people to bear in mind if you're going to be living near a busy road with an MVHR. In fact, any house, most houses, you're not going to see this kind of infiltration because it's invisible. The only reason I noticed is because it was focused in a very small area. But I'm glad I found out, and I've dealt with it. Just need to change the filter every couple of years, and I'll be particulate free, I think. And that brings me to pretty much the end of the bungalow renovation. We're ongoing. I'm currently rendering the EWI in the bungalow. Did it last weekend. My wife's glad that she no longer has to stand on her tiptoes to reach the washing machine and the tumble dryer, because they were 3.5 feet off the ground for a while. But yeah, I'm getting on with it still. So are there anybody have any more questions about the renovation work?
Well, maybe I can ask one while you're
Okay.
preparing this. And so, yeah, I'm wondering about, how you're enjoying the fruits of all this work. What is the kind of the best comfort or usability improvement that you're experiencing?
Oh, comfort is absolutely fantastic. You wouldn't believe how stable the temperature is. I remember before I turned any heating on in here, the first coming up to the cool season, I noticed that the temperature was dropping outside, and I had a little thermometer inside, and the needle didn't move. It takes 24 hours to lose 1 degree of heat, while the temperature outside can swing up and down by 20 degrees. Nothing, it just doesn't change inside. And the very small amount of energy it takes to heat the property. I mentioned earlier when we had gas heating in the bungalow, 27 megawatts of gas in just over 6 months. Maintaining the same temperature in the extension continuously day and night for a year, a whole year, we only use 3 megawatts of gas. So that's almost a 10-fold decrease in gas. And for a constant temperature, it doesn't swing very much. I mean, it does have a downside in that it can be a little warm at bed, in the bedroom, but you just change the quilt and you learn to live with it. But yeah, I would say that's just, you've got to experience it to really appreciate it. And the slightly lower humidity level as well, because of the MVHR. Just the environment, the air feels nicer to breathe. And I joked when we moved in, because my wife said, there's no radiators, when we're going to dry my washing. And I said, oh, you can't dry your washing in the house. And then I said, jokingly, I said, you can just put it on the kitchen floor to dry it with the underfloor heating. And she sort of thought that was a joke, and until she wanted to dry one of her knitted garments. And I said, you can put it on the floor to dry, which she did, and it dried within a couple of hours. So she's been doing it ever since. Any more questions?
I think Stuart's got a question about the floor height. Stuart? Go ahead, Stuart. Okay, we're still, I think is that you, Stuart? Okay. Well, Stuart says, did raising the floor height in the bungalow cause any problems?
No, I didn't raise the floor height in the bungalow. I took out the suspended wooden floor, and there was a 350 millimeter void underneath the floor, which was almost perfect really for my my application of insulation. I had to put an extra ground bearing slab down to start with, and then just built up the insulation on top of that, with a flow screed on top with the underfloor heating pipes in it. So it all worked out quite nicely, although I was aiming for an extra 20 mil. I didn't quite get it, but I don't think I'll ever notice. I'm just sharing a screen with you now, which shows a little bit of data of the house, also the extension, which is, I've only got a week's worth of data. This is from Permetrics. They lent me some data logging equipment. You can see I've just put temperature sensors around my house. So I've got one in the shower room, and one in the bedroom, one in the kitchen, one upstairs. And the blue line you see here is the weather station temperature. So that's the external temperature. That's going up and down day and night. And you see the internal temperature barely changes. And we certainly haven't got any heating on at the moment. It's a little on the warmer side. It's nearly 24 across the whole building. The upstairs temperature follows the outside a little bit. You can see that the dark green one where it peaks here, the upstairs temperature, just following the peak of the outside temperature. But the rest of the rooms downstairs, they're all pretty constant. Very little change. And that's what you see throughout.
Sorry, this is a week's worth of data.
It's only a week's worth of data. Yeah.
I think Rosemary's got a related question. Rosemary?
Hi, thank you very much. Do you have any overheating problems in the summertime, and we live up in Manchester. You're obviously in the south, much warmer down there. But with that very hot weather, how did you manage it, and how did you keep cool?
Yes, it got very hot, and I have experienced some overheating in the extension that we have here, and my conclusion is I think most of that heat is solar energy, solar gain, which comes through the roof windows. And I did expect, well, I didn't expect it quite to overheat as much as it does, but I did think it might do. So I have got plans going forward to limit that solar radiation getting into the upstairs windows. Right at the beginning here, this red plot, this was the end of last week or the week before, forget when it was now. And that was when we open all the windows in the house at night and leave them open all night. That's why the temperature dropped right down by about 3 degrees. But I just tried to lose as much heat out the house as possible in the evening. And it works reasonably well. And then in the morning, I go around and shut all the windows, and the outside temperature, can shoot up again, and you lock most of it out. But my plan going forward for both the bungalow and the extension is to fit solar shading, which will be fixed louvers on the outside, which should just protect from midsummer sun for the bungalow windows. And for the extension windows, I can purchase they're electrically operated external blinds. I fitted blinds on the inside, thinking that might limit the solar gain inside, but it barely made any difference. So I think what it really needs is external blinds, just to absorb that radiation, turn it into heat, and keep it outside the building, which the windows will do nicely. And that's a project for some way down the line. You can buy these external blind kits for a few £100. They're remote control and they're battery operated, solar battery, so sort of almost fit and forget. You just have to remember to close them when it's going to be sunny.
Thank you very much.
That's great. And I think John's got a follow-up question as well. John.
Yeah, in hindsight, would you do anything differently? Looking at the pictures, I was just curious about the timing of the MVHR. So if you're doing
about the what? Sorry, then. What about
the timing of the MVHR? So sorry about the loud computer. So if you're doing dusty work, do you tend to suck dust through your MVHR, stuff like that?
Yes, yeah. I've created so much dust. I mean, I did create a lot of dust outside as well. I just have to remember to change the filters regularly. I mean, interestingly, the outgoing filter captured just as much dust as the incoming filters. So there was, I mean, it's not completely sealed between the bungalow and the extension. So some dust was getting through when I was angle grinding and doing very dusty things like that. It's hard to do it anyway, any different. I don't know how else I would do it. I mean, you could move out. We could have moved out of here and lived somewhere else, but it's been such a long project. It just wasn't practical. I know I've always lived on site. My wife's quite used to it. Poor lady. She's had to suffer me doing DIY for our whole life, the whole marriage. But she's very tolerant.
Are there any other follow-up questions that people haven't had a chance to post in chat that would like to ask now?
Can I ask one more while others think about a question? There is still time. But Mark, in the long run, are you thinking about using a heat pump to heat this, or are you going to gas? What's your thinking?
Well, when I conceived the work here, let's just go back. I planned to use a gas boiler because it was the cheapest way at the time. I'm talking in 2013, 2014. Heat pumps were quite a lot more expensive then. They're certainly a lot more expensive than they are now, and expensive to install. And I just couldn't justify it on my budget. My whole budget for this build, for the building and the renovation, is £150,000, and I'm still well within that budget, and I'll probably hit 150 by the time I've finished. And to add in 20+ thousand pounds for heating, for a heat pump, it just didn't make financial sense at the time. I'm glad I didn't do it. I did spend a lot of time looking at heating and decided in my own mind that I didn't want to have a heating system that with a gas boiler that put out 70-degree temperature water, and then it got blended down to 25 degrees maybe for the underfloor heating. It just seemed an odd way to do it and a waste of energy. And the boiler doesn't run at its maximum efficiency then. So I looked and searched because I thought there must be a way to control a boiler to modulate the temperature and modulate the water temperature down to, what you want for your underfloor heating. And after a lot of searching, I found that Wiesmann make just such a boiler. They have a 4-pipe system. So one pipe goes to your heating circuit and one pipe goes to your hot water tank. And then you have 2 return pipes. And the boiler then has a valve inside which switches between the 2 outputs. And for the hot water tank, it switches to 70-degree output. And the rest of the time, it modulates the hot water down to whatever you require for your underfloor heating. And basically, I set that for the temperature that we want in the room. It's weather compensated, and it just works. We don't have to touch it, do anything to it. We just at the right temperature all winter. And that's just the sort of system that I was hoping to achieve. Minimal input of any kind from anybody. You just turn it on and it works. And forget about it, really. It's been very successful so far. I will be able to replace it with a heat pump in future, absolutely. But I've got to wait for the boiler to break down.
I've got 2 sort of short questions, really. So your manifold for all the different heating zones looks really rather impressive. How many zones did you put in?
So for the extension, I put in a loop for every main area. So just escape from there. If I switch back to this one, so there's a ground floor plan. So in the extension, I have 2 loops in the kitchen because it was too big for 1 loop. And then I have 1 loop which covers the hall area all the way around there. Another loop for the bedroom and another loop for the shower room. So that's 1, 2, 3, 4, 5 altogether. So that's quite a big manifold. And then in the bungalow, I haven't got a ground floor plan, but the bungalow was 1, 2, 3, 5 again. And I think that's a 5-way manifold as well. So I have 10 underfloor heating zones. And once they're balanced, you have to control the flow rate going through them, which you can work out quite easily. I did use an underfloor heating specialist to do the first design, but shortly after that, I realised it wasn't that difficult at all, especially after talking to them about pumps and blending manifolds. And I said I really didn't want those. And after a bit of toing and fro, they said, yeah, your idea will work fine. Like, well, yeah, okay. So yeah, it's fairly easy to do the calculation, but you adjust the flow rate until you put the right amount of heat into each area, and it's just worked. The only thing I did do was actually within about 2 days of moving in, I turned the manifold off completely in the bedroom because it was just too hot, and we haven't had it on since. So even in the middle of winter, with no manifold in the bedroom. The bedroom is probably about 1.5 degrees cooler than the other rooms. And that's all, really. There is massive thermal mass within the building. I made sure that everything was done in a heavy thermal way, if you like, to give it thermal mass. So the walls being, I know they're only lightweight blocks, but they're quite thick. And then on top of that, they've got cement render and plaster, so that it's a solid surface for the heat to soak into, and the floor is 60 millimeters of, screed, which stores a lot of energy for a long time.
So I think
Yeah,
I think we should wind up for our 8 o'clock finish now.
okay.
But I do see
Yes.
there are still some more questions. So what we'll do is I'll just come to the final couple of slides and finish off. And then you're welcome to leave if you need to. But if you want to carry on this discussion and hear the remaining questions, we shall have a bit of extra time after that. So, Mark, can you put us to the penultimate slide?
Yes. Quickly zoom through them.
Yes, this one.
That one.
And so you probably expect that I'm going to ask you to make a donation if you're able. Open Eco Homes is a project of Cambridge Carbon Footprint, a charity, and so we're very much dependent on donations and grants. People shown at the bottom there, some of them like South Cambridgeshire and the Cambridge City have given us grants, and the others are sponsors of Open Eco Homes. But anyway, your contribution would be great. There's a link. And if you're into social media, please share your experiences or things that you enjoyed about this presentation, anything to add to social media about Open Eco Homes. Thanks. And final slide, please. And so, so there's other things you might do to get started with your retrofit if you haven't already, or maybe you're not quite ready for that. You can be planning it, or you can be doing other home improvements as a result of this. You could book another tour or talk. I think Nicole will be putting up links for that. Or you could look at our previous case studies. Have a look at Mark's one as well. There's 2 sides of PDF with a lot of links and further information, or have a look at the slides. And we've got thermal imaging cameras that we will have on loan from November. We ask you to come to a training session first so that you get to understand what the thermal images are showing you. And it's just a great way of revealing where your home is leaking heat. And it's a good resource there from Transition Cambridge. And one event I think I'll plug generally is in October, we have an event called a Human Library. We have a large selection of home energy experts, and you can book to have a short session with a home energy expert and have a one-to-one exchange where you can ask questions about your particular issue. In the time available, you're not going to solve everything about your home, but we hope that will give you some really useful advice. So look out for the Human Library. So thanks very much, Mark. I think this has been a really useful presentation. And I hope other people will enjoy it and make use of it in the future. And thank you for everyone else in participating. And so do hang about if you want to go into this 2 minutes past 8 already. So we can take a little bit more time to finish up the questions if you want. Thanks very much.
Yeah, thank you, everybody, for listening.
So I think Sandra was asking about the boiler. Sandra.
Yes.
Sorry?
Yes, thank you, Nicole. Yeah, I just wondered what sort of boiler that is. I was recommended to a website called Heat Geek, and told about condensing boilers. This would be as an alternative to a heat pump. Yeah, so unfortunately, I'm in the position of I have a desperately dying boiler in my property that I rent out, and I'm doing things the wrong way round. I desperately don't want to put gas, a new gas boiler in, really. The building is up to D on the energy performance certificate. It would be much better if the building was empty and I could just do it or have a retrofit done and make it as airtight as possible. But I'm not in that position. So I'm really bemused about whether I should even be putting a heat pump in. But an alternative, I was told, was a condensing boiler. So, and it doesn't sound as if the one you've put in is a condensing boiler.
Just about all new boilers now are condensing boilers. I'd be surprised if any of them weren't nowadays.
Right. Yeah, I did read that most are, but actually in the house I'm in, that is 10 years old, it doesn't appear to be a condensing boiler. But anyway, so yeah, right. So that, yeah.
You probably want to, I mean,
that.
My personal opinion, everyone's got their own opinion. I would stick with the gas boiler. I would get a good quality Bosch Worcester gas boiler, because unless you do, some renovations, retrofitting to increase the insulation and airtightness, then you're going to lose a fair bit of heat still. And in the winter you'll be using a lot of electric with a heat pump.
Yeah, that's what worries me. Yeah, and that would be expensive.
Yeah, so I expect Sandra, about the boiler upgrade scheme. But I put a link in chat.
Yeah, I know about the grant. Yeah.
So it's a £5,000 grant at the moment.
Yeah.
For switching to a heat pump. But yes, don't do it unless that's the right thing.
Yeah, well, I don't want to. If a heat pump was using more, my tenant asked me today, could we actually be using more carbon, or putting more carbon out by using a lot of electricity for a heat pump, because of the heat loss, rather than having a better gas boiler. I mean, is that possible?
So I think typically the bills are similar between a gas boiler and a good heat pump. But in fact, the heat pump is lower carbon, because now that UK electricity is so much coming from renewables and nuclear rather than fossil fuels, it's a lower carbon energy than gas, and that process will continue in the future to
improve.
It will improve, but we're still producing 45% of electricity from gas.
Yeah, that's is one of your concerns, Sandra, because of the 2025 requirement that landlords have to have a sort of a C rating or above if they're renting out property?
No. In fact, I'm not actually aware of that. No, my concern is just I don't like gas. I don't want to be using fossil fuels, and ideally I'd bought a place, be retrofitting my own place, finding out all the pitfalls, having it all done, know what to do, and then I intended to do my bungalow. But this 30-year-old boiler is actually costing money now, breaking down. So I've sort of got to make this. I've got to make a decision this autumn. It's got to be changed this autumn. So it's what would save, what would produce less carbon, but also the cost to my tenant.
Yeah, it's a bit of a tipping point at the moment. It's finally balanced between heat pumps and gas boilers, how much carbon they use or consume in their life. Tom's right. We will reduce how much electricity we produce by gas, and then it will be more effective. But cash wise, you're never going to beat a gas boiler, even with the rebate.
Mm.
know, you can just put a new gas boiler in, and you're not going to have to pay £8,000 for all your radiators changed.
Mm.
It'll
But
just work.
right, on Heat Geek, it recommended that with condensing boilers. Okay, so that's the standard now. That actually the bigger, the newer radiators, the double ones, were better because you could have a low flow temperature.
Yes.
Or you could, yeah, you could modulate the temperature flowing from your boiler.
Mm.
Yeah, you could do that as well, but it would save a little bit of gas by doing that.
Yeah.
Is there any way to insulate the property? Because if you can reduce the amount of energy you need, then whether it's coming from gas or electricity, that will certainly help reduce emissions. So if there's any way of reducing the energy demand, insulation is usually the best.
Yes.
If it's an option for you.
Yeah, it's got the 300, mils insulation in the loft.
Yeah.
It's got it's 30 years old, the bungalow. It's got a concrete floor. So, ideally, before it was rented out, it could have had insulation on top of the concrete floor. It's got cavity walls. I've had it was suggested perhaps that there wasn't insulation in them, but I've had it checked and been assured that there is insulation there. So it's difficult. It's got double glazing. It's expensive to replace that with triple, isn't it? I don't know what else to do really to reduce the heat loss.
So Sandra, I've put another link in chat to the scheme that Nicole was mentioning, the MEES, or Minimum Energy Efficiency Standard for rented property. And so this is a government scheme whereby they're going to increase to rent out property, you have to have it better than an F, I think. EPC, which is not very demanding, but they're planning to increase that to a C, which will be more demanding for rented out properties.
And that's for 2025. 2025?
That's the current target, but some people are cynical about whether this will happen that quickly.
Yeah,
it's coming, and so do look into that.
Yeah,
it is going to be important.
Yeah, it's a good thing. Personally, I'm not quite sure how I would get it to that, but yeah.
So at the moment, in fact, you only have to, as a landlord, you have to spend up to £3,500 improving your insulation, etc. And that you're not required to spend more than that.
Yeah.
But the details of the tightening of this scheme are yet to be announced, but they are promising it'll get tighter.
Right. Yeah.
I think maybe have you had a chance to use a thermal imaging camera, Sandra? Because that might give you some clues as to where the heat loss is.
No, we did borrow one, but we used it in our own house, which is only 10 years old anyway, just out of interest, really. It might be worth me borrowing that. I did take it with me there, but it was one that was the battery kept failing. So
oh no.
So
the
used it there.
I don't know if it was the one
from
Cottenham who were hosting them last year. That particular camera has had its battery replaced now.
Yes.
So in the coming season in November, we plan to be lending out 15 cameras. We had 9 last season, and we couldn't fully meet the demand. There's a lot of interest in this.
Yeah. Yeah, that might be worth doing again. Yes, doing that in the bungalow. Yeah.
So, is there anyone else with a question to come, or anyone want to share their experience or make a useful point.
Colin, anything you'd like to ask?
Yeah, well, I'm Sandra's partner, so
Right.
the background. I think going from what a master builder was saying, excuse me, I've forgotten your name now. We go with the gas boiler, the Bosch whatever boiler, and two surveys have indicated that yes, we've got insulation as required to the present standard, but really, if you're going to go for the heat pump, then it'd be worth upgrading the other insulation. And the 2 years time, if that relates purely to insulation, then you could do the insulation either external or internal, and the boiler would still be running okay, still acceptably, until such time as Sandra says, if we move and do our own house, then we might have a bit of cash left over to do the bungalow. But it seems a bit ridiculous to pay out that money on the bungalow, and then we move and we've got to do it again ourselves. Whereas the other way around, we've got a bit of cash to spare.
Yeah.
So there are. It's not just insulation that affects the EPC of a home. For example, if you have solar panels, solar PV on the roof, that will improve your EPC. So several factors involved.
Yeah, we've got panels on our house, but not on the bungalow.
Mm-hmm.
Could you switch out lighting? Because if you just switch everything to LED, that's a quick and cheap way to do it. If they'll have a list, and you just work through things that you think are actually realistic for you, which would help. But if it is too costly, there is a clause within the government guidelines which says if it's above a certain amount where it's too expensive for you to upgrade, you can then ask for a special exemption. So you'd still be allowed to rent it out, because it's unrealistic for you to expect to spend thousands and thousands to reach that C grade. So there are special exemptions, but I think that, like Tom was saying, that there is every possibility that over the years they will start to tighten those,
which is good. I agree.
I would just say that when we bought our house, the electrician who was then working for the builders said, the LEDs are going to come into requirement next spring. And they said, oh, that's next spring, we won't worry about that. So when we bought the house, took it over, we had to change and pay for all the lights to be switched over to LED. So I thought it was pretty mean of the builders to, for the sake of a few £100, not putting the LED lights in. But that's your builders. You've got to keep an eye on builders.
Yes.
They weren't building for us. We found it fully, it was finished when we found it.
So
anyway,
I think it's probably time for us to be winding up and going to enjoy the rest of your evening in other ways, I hope.
Thank you.
Thank you very much to Mark especially, and everyone who's
Sorry, Mark, I forgot your name. It's good getting old, does it?
Good. And I hope people have got new ideas about how they can improve their home. Thanks very much.
Thank you.
Thanks, Aaron. Bye, everyone.
Bye-bye.